Question 4, we've got our mean and variance questions. So I've ripped the table out there. So we're going to find my XP column. That's a row here. And just times all these things together. 4 times a half is 2. Add all that up. We'll do that in a second. And then we've got x squared p. So this times this again. So I've got 25 over 12. I've got 4 over 6. I've got 9 over 4. And we've got 8. So this one here is the expected value of x, and that works out to be 2, doesn't it? And this one here is the expected value of x squared. Expected value of x squared there, I think that's 13 if I had that up correctly. And so my variance is the expected value of x squared. I want to leave more space for the rest of my table, so I'm just going to move down a bit here. So the variance is the expected value of x squared, take away the expected value of x squared. So 13 take away 2 squared seems to be 9 there, doesn't it? Let's just check it all on the calculator. So the x values were -5, -2, 3, and 4. The probabilities were 1/12, 1/6, 1/4, and 1/2. What did I do there? Didn't put the 2 in. And calculations, 1 variable. So the mean is 2. That's what we said. The sum of the x squareds is 13. That's what we put there. And look, I've got here the standard deviation is 3. And so the variance will be 3 squared, which is 9, which we have there. Right, so part B. When x is negative, y, this is why I wanted the extra space, because I wanted to do y here. Y is equal to x squared. So x squared there is 25. X squared there is 4. But when it's positive, it's equal to 3x take away 2. So 3 3's take away 2 is 7. And 3 4's take away 2 is 10. And we were asked, what's the probability that it's less than 9? The probability that x is sort of that y is less than 9 is that one and that one. So that's probability that y is less than 9 is equal to 1/6 plus 1/4, which is 5/12. So that could have been on a maths paper rather than a further maths paper, couldn't it? And the last bit, the x times y. So xy are these two things times together, so that's -125, that is -8, that is 21, and that is 40. And if we times that by the probabilities each time, so, and I think I might need to use the calculator to do that. So I'm doing -125 divided by 12. Yuck. I just should have written -125 over 12, shouldn't I, there? Let's do that. -125 over 12, -8 over 6, 21 over 4, and 40 over 2, although I do know that one. X, Y times by P. And if we add all of those up, then we're going to get 13.5. 13.5 there. And yeah, I'd go ahead and check that on the calculator by putting these values into the into here again. I'd just put these -125 there. I'd stick the -8 there, the 21 there, and the 40 there. And then again, just do the one variable statistics. And again, look there, 13.5 is the mean of those things there. Nicely checks that n is still 1, because of course your probabilities have to add up to 1. So again, 8 marks there, not particularly difficult.